Hello, 7th graders, and welcome to lesson 15.5, which we are going to talk about independent and dependent events. Remember, within this unit, we're talking about probability, so we're talking about independent probability, so things that are not related, and then dependent, meaning they relate on each other. So something's going to happen, and then it's going to cause an effect, or there's going to be a cause and effect with the other part. So our objectives are I can identify independent and dependent events. I can use formulas to find probabilities of independent and dependent events. All right, so our essential question is what is the difference between dependent and independent events? Well, I kind of started explaining that. Dependent means they depend on someone, okay? They go together. If you're independent, think about what independent means, okay? This means you're on your own. Okay, not related to one another. I think this was a warm-up part. We're skipping this. I think this is a warm-up part. Let's look. Yeah, that was something else, the warm-up that somehow got mixed in there. So when we talk about the probability of independent events, meaning that there are two things that aren't going to relate to each other, okay? And we'll take a look at some examples of those and explain more so what the independent events mean. But the probability of independent events means the probability of two or more independent events is the probability of the possibilities of that event. So this is a lot like that fundamental counting principle, okay? So what's the probability of A happening? What's the probability of B happening? So on. And we just multiply them together. Now, it's not the total amount of outcomes, it's the probability that is happening. So let's take a look at an example of an independent event. Oh, I think this got cut off a little bit on the words. Yeah, there we go. Okay. So as you spin the spinner and flip the coin, what is the probability of spinning a prime number and flipping tails? So these are two separate things. It doesn't matter what you spin on here, the coin is going to flip however it wants. Or if you start with the coin, it's going to flip however it wants. And then you spin the spinner and the spinner is going to do whatever it wants. Okay. So we want to know what's the probability of spinning a prime number and flipping tails. Well, let's start by looking at our coin because you only have two outcomes on a coin, okay? So your probability would be out of 2, and the only time that it's going to flip tails is 1 out of 2. So that's the probability for getting a tails on a coin. Now, this is up for debate. I was going to Google this here. Prime numbers. Again, I don't feel like they count 1 as a prime number. I'm going to Google it and see. Yeah, prime. 1 is not a prime number. Okay. So remember that prime numbers are anything that you can divide only by itself or 1. So in this case, 1 isn't. We just don't think of 1 as 1. But 2 is because you can only divide 2 by 1 or divide it by 2. 2 is. 3 is. Same thing happens. 4 isn't though, because 4 we could divide by 1, we could divide it by 4, and we could divide it by 2. But 5 is. So on this one, you have a possible of 5 different things to happen, and 3 of those are prime. So to find out the probability that I land on a prime number and flipping tails is I multiply these two probabilities. So I'm going to take 3/5 times 1/2. When we multiply fractions, we just multiply across. 3 times 1 is 3. 5 times 2 is 10. And at the end, we would want to simplify, but this one is already simplified. So your probability of that happening is 3 out of 10. Get a little wet. All right, so on your own, let's see here. Is the probability of spinning a multiple of 2 and what's the probability of spinning 2 and exercise? Don't worry about this part. I don't know where this came from. All right, so what's your probability of spinning a multiple of 2? So we're just using the same one. Okay, what's your probability of spinning a multiple of 2 and flipping heads? So go ahead and figure out that probability. Figure out the probability for each one and then multiply them together. When you get back, we will have the answer. Alrighty, so your answer then is going to be 1/5 because the probability of flipping a heads is 1/2. And your probability of spinning a multiple of 2, remember you could have 2 or 4 that are both multiples of 2. So that would be 2 options out of the 5. Multiply them together, I get 2/10, but I want to simplify it down to 1/5. All right. Moving forward. I know I'm going kind of fast, so if you need to pause this at any point or go back through the video, you can do so. Let me know if you've got questions or if you want to get on Zoom with me and I can answer any questions you might have. So now we're going to talk about dependent events. So the probability of a probability of 2 dependent events, A and B, is the probability of A times the probability of B after A occurs. So this is where it gets a little tricky and you have to understand which are independent and what are dependent events, okay? So we're going to take a look at what is a dependent event, some examples of them, and how do we solve them from this. All right, so here is a long wordy word problem. Let's take it step by step and pull out our pieces. So people are randomly chosen to be game show contestants. Ooh, from an audience of 100. Are we playing like Price is Right? Love that show. All right, you are with 5 of your relatives and 6 other friends. What is the probability that one of your relatives is chosen first? Then one of your friends is chosen second. Ooh, this is kind of tricky. So there's 2 parts to this. So what is the probability that one of your relatives is chosen first? I'd almost even circle this part. Relatives chosen first. Ooh. And then one of your friends is chosen second, okay? Friends then are gonna be second. And we had 5 of our relatives and we had 6 of our friends, and there's a total of 100 people. So we need to think about the probability of each thing happening, okay? The first one is what is the probability that one of your relatives is chosen first? Remember, probability, we always take the total amount on the bottom. So there's a total of 100 different people, so there's 100 different choices. Of those 100 different people, probability that one is a relative, well, how many relatives did you bring? You brought 5. And for right now, it's okay if we don't simplify it, okay? We can simplify it here in a minute if it's a little easier to do out our mathematics. But there's a 5 out of 100 chance that one of your relatives is going to be picked to be on this game show. Okay. And then it says, and then one of your friends is chosen second. So if you've ever watched things like The Price is Right, what else pulls from like the audience? I don't remember. What's the one where they dress up funky? I can't remember. So they already pulled someone from the audience though, and so that person's already on stage. So now your total amount of people though changes because your total amount of people now is not 100. That person didn't return back. He's still on stage or she's still on stage. So now you only have a choice of 99 people. Okay. Of that probability, 6 of them are your friends. So we're going to have 6 out of 99. Okay. Let's multiply across and then we can simplify if we need to. But I could multiply across. It's going to give me some weird numbers, but let's go ahead and simplify these. So 5 out of 100, I could divide the top and the bottom by 5 and get 1 out of 20. And 6 out of 99, I think I could get rid of a 3 here. 2 out of 33. Yeah. All right, multiplying across, I would then get 2 would be 20 times 33. 660. All right, and if I simplify that, You divide a 2 from the bottom and the top, so that'll be 330. Yeah. So there is a 1 out of 330 chances that one of your relatives is going to be picked first, and then one of your friends is going to be picked next. That's a pretty slim chance. I would say it's probably unlikely, almost impossible. Not quite impossible. I'd say very, very unlikely that that's going to happen. All right, so I want you to try this one. What is the probability that you and your relatives and your friends are not chosen to be either of the first two contestants? So you got to think about how many other people are not you, they're not your friends, and they're not your relatives. And you're taking the first two spots, okay? I want you to try and work this out. Once you have your answer, come on back and we can check your work. Okay, so pause the video, solve out the problem. I mean pause it. Alrighty, welcome on back. As you can tell, my work is very messy. So what I did is I first started by looking at who were all the people you didn't want to choose. So you didn't want to choose your relatives, your friends, or you. So that's where this 5, this 6, and this 1 comes from. So that's a total of 12 people you don't want to have as a choice. So out of those 100 people, there's 88 people you don't know. So when they first pick the first person, there's a chance of 88 out of 100 that it's not someone you know or yourself. Then once they've already picked someone and they put them on stage, that means there's one less person in the audience, so you're down to 99, and one less person you don't know now in the audience. So then it goes down to 87 out of 99. Okay, that's where these dependent changes some of that probability. And so ultimately, if you just multiply across, you get this big answer. Oh, I don't know why it doesn't like me swirling around very much. So there's 7,656 out of 9,900. I tried to take some steps to simplify it. So I divided by 6 first, and then I divide by 4. I'm getting a little stumped past this part. When it's big numbers like this, don't worry too much about simplifying it. I'm not sure if Big Ideas really needs it to be simplified when it's this big. They might want it as simplified as you can. If anyone can figure out what it is, if this is the simplest form, the 638 out of 825, let me know. Otherwise, if you can get further down, put it down below in the comments as well. All right, let's see how much we have, because I want to see if we can get through it in this video. Not much. All right. Let's finish off here. So I want you to go ahead and close out this video, and I will catch you then in part 2 of this lesson. Okay, keep watching for your code word. We will go through example 3, and then we will continue on. Catch you in part 2.